Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Kate. And Kate, if somebody needed to get in contact with us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Kate, where do you go to school and what grade are you in?
I go to Ronald Reagan Elementary School and I'm in 6th grade.
How is 6th grade?
It's good.
It's good.
It's
not
awesome.
Great. It's not bad. It's just good.
No, it's great.
It's great. What's so great about it?
Well, I love my teacher and my principal.
Good. You know, you're the first kid that has ever said they love their teacher and their principal. That's kind of odd. Anyway, we'll find out a little bit more about that later on as the show goes on. So, the 6th grade is great. You love your teacher. And because you're in the same classroom all day with that teacher, correct?
Yeah.
All right, so junior high, you can have a lot of them, probably like 6 or 7, maybe.
Yeah.
So are you getting used to thinking about that, or have you not even thought about that yet?
Well, I've kind of thought about it.
Kind of thought about it a little bit? Well, you still got a little more than half a year even to worry about that. But I know one thing that you've been doing in your classroom is working with percents. So why don't you head over to the board real quick, and you can write down anything that you'd like to, but explain to Scott in a moment or so kind of your understanding about percents, just overall about percents.
There you go. Grab one of those pens. What do you know about percents?
Well, like 2% would be like...
That's okay. So 2%.
would be 2 over 100 because a percent would be just over 100.
Okay. I like that. So you can change a percent to a fraction, right?
Yeah.
Those two things are equal.
Yes.
And cents, right? There's 100 cents in a dollar.
Yeah.
This is 2 over 100. I like that. Can you change it any other way?
You can also make it 0.02%. Or I mean, not percent.
0.02, yeah.
Yeah.
So a percent can be changed to a fraction. It can also be changed to a decimal.
Yes.
Do you have a way that you know for sure? Like that says 2, right? Just 2%. The next one says 2 over 100, but then you have a decimal there. How do you know which direction to move the decimal and where to put it?
Because this is the hundredths place, and that's 100 as the denominator for the fraction.
I think that's a great way to explain it. So we're all dealing with hundreds, right?
Yes.
100 as far as percent, 100 over, which is your denominator in your fraction, and in the hundredths place. It's a wonderful way to look at it. Here's a question right before we go back. Can you have a decimal in a percent?
Yes.
You could? Can you give me an example of that real quick?
Like 5.4%.
So you can. So you can mix them up a little bit too, huh? Interesting. Maybe even have a fraction with a percent. We'll see about that later, but I think that's a good way to look at the percents initially. Good job.
There you go, nicely done. So you got some basic knowledge about percents and different ways to represent a percent. 636-4357 is the phone number. We usually have phone tutors available on Tuesdays and Wednesdays between now and 5:30. And now You guys ready?
Ready.
It is time now for today's Math in the News. And here we go. We are celebrating 20 years on Do the Math. And you can see some photographs of some of the past tutors and people that have taken part in the program. And there are a lot of people behind the scenes that you don't always see that help make this program run. And we will be meeting all of them this year at one point or another, because we've kind of divided the year up into one half of the year, the people that you're used to kind of seeing on air and helping the students with a lot of the math work. And the second half of the year, we'll be focusing on more of the people that you don't see. More than likely, you have never seen them, but you will see them during the second half of the season. So for all of you that didn't know this was coming up, surprise, you're going to be on during the second half of the season. But one of the gentlemen that was able to start with us, it wasn't at the very beginning 20 years ago, but Matt Kennedy was part of the program. And Matt, thank you for being here this afternoon, first of all.
Thank you. It's my honor. Thanks for inviting me. I've been looking forward to this for several weeks, actually.
Good. Do you remember when you were on Do the Math?
I was here about 18 years ago.
Okay.
And,
I remember it was pretty close to the beginning. Mm-hmm. And how did you, first of all, hear about the program, or how did you get involved with the program?
Well, I think I heard through word of mouth, and I talked to some different people. They said, hey, there's this show called Do the Math. You love tutoring math, you love coaching math, you love coaching math teams, and this would be an opportunity for you to work with kids who need help in math, or help those who want to do advanced math as well.
And where were you? Like, what were you doing when you first started with Do the Math?
I was a teacher at Loudon Elementary School, and I taught 6th grade at that time.
And Loudon, now, was that your first assignment, or had you been someplace else before that, or?
That was my first assignment in the Panama Buena Vista Union School District. Prior to that, I had worked for Cesar Chavez Elementary and Bakersfield City Schools.
Okay. And so you were at 6th grade Loudon, and did you stay there for a while, or were you an elementary teacher for a while after that? Did you move around?
I was a elementary school teacher for 9.5 years total, but I was at Loudon School for 7 years.
Okay. And while you were on Do the Math, do you remember, can you recall any instances of things that may have come up that are memorable, let's say?
Just getting to be a part of it, getting to be a part of that phone bank and having all those textbooks out, and you think, oh, I've got all these problems memorized, I can work through them. And I get a phone call from a kid who was a junior or a senior, and he needed help with some calculus. And I wasn't well versed in that. And so thankfully we had someone who was a Cal State professor, I believe at that time, or working for the university, and was able to step in and help out on that.
Yeah, because I remember years ago, the phone tutors would be in the studio with us, and there would be a couple of tables over there, and there would be anywhere between 5 and 7 of us in here, and those phones would ring. And when you're up here, that's distracting. And then when you're on the phone trying to talk to a student, you've got other people right next to you talking about their problem with another student and what's going on up here. So eventually the county office and those higher up, John and those guys decided, hey, let's get the phone tutors out of here and into another room to make everything a little bit quieter for everybody doing what they were supposed to be doing.
And there was one other memorable event. I had the opportunity to be on air 3 times. Okay. And leading up to a particular day, you come in and you're used to your routine, and you rush from school and you get here. Right. And a person wasn't able to come that particular day. And so I believe it was you that said, hey, are you available? Are you ready to go on air? Do you feel comfortable going on air? Yeah, sure. When do you need me? You're on in 3 minutes.
Well, that's usually the way it goes. It's like, hey, you ready? You feel good? Now, go. But so it wasn't a bad experience.
That was awesome.
Yeah.
Absolutely enjoyed it.
And that hour flies by, doesn't it?
It absolutely does.
Indeed. Well, we certainly do appreciate you taking some time to come visit us again. We appreciate your time with Do the Math at the beginning of Do the Math to help keep it going. And like I said, it takes a lot of people to get this thing going, and to sustain it over 20 years takes a lot of people, a lot of modifying, and a lot of commitment from all of those involved. So what do you do now?
I'm this elementary school principal. This is my 15th year as a principal, and I'm currently the principal at Ronald Reagan Elementary School.
All right. Well, you know what? We've had some great students call in from Ronald Reagan, and we've had some fantastic students in studio with us. And one of them, Kate, happened to say today that she loved her teacher and her principal. So now, Kate, I can see why you said that you love your principal, right? So, I don't want to put you on the spot. Have you ever had to go to the principal's office for a behavior problem?
No.
All right, good. Let's keep it that way. All right. Matt, thank you once again for coming in, and know that at least you've got one of the kids at the school that loves their principal, and I'm sure many others do. I know that you've been at Reagan for a couple of years, and we certainly do appreciate everything that Reagan does with the Panama Buena Vista School District, and I know that Katie Russell, the superintendent, is very appreciative of your past efforts and participation with Do the Math as well.
Thank you, sir. It's
All
been an
right.
honor to be on. Thank you.
Thank you once again for
You bet.
coming in. All right, that is today's Math in the News. 636-4357 is the phone number. Kate, as we just said, a sixth grade student from Reagan Elementary, is in studio with us right now and about to work on a problem. So, young lady, back to the board. And if you would be so kind as to erase all of the previous work that you have up there. And we have one of your homework problems that we're going to work on right now. So it said, if the salary cap in baseball increased from 180 million, so let's go ahead and put 180 million up on the board. Oh, Scott's taking care of that for you already. So the salary cap increased from $180 million to $200 million. We would like to know what percentage of increase that was. So not the dollar amount, but the percent increase.
All right, Kate, what do you want to do with this one?
So first you have to find the change in dollars.
Oh, I like it. Okay, let's do that. I'm just writing down what we need to find, right?
Yeah.
We want to find the
So-
percent increase. So let's find the change in dollars. Great first start. How do you do that? How do you find the change in dollars?
To find the change in dollars, you would have to subtract the larger one from the smaller one.
Okay.
So that's 200 million minus,
Can you do that in your head, Kate, or do you need to write that out?
I can do it in my
Oh, I like
head.
it how you're doing
Okay.
some words there. That's
I was
actually
going
nice.
to say
It'll
to
work out pretty
shorten it
well.
up a little bit there.
Yeah, absolutely.
Would be 20 million.
20 million, no big deal. So did it go, now tell me this, did it go up or down 20 million?
It increased.
It increased, gotcha. So we're finding the percent increase. That makes sense so far. We always want to make sure our numbers are making sense. Okay, so what do we do with this 20 million?
You place it over the current price, which would be 200.
Now tell me where it increased from.
It increased from the original price to the current price.
And if you want to know how much it increased, we have to be able to compare it to the original, right? That's how much it increased, but we want to know how much it increased from the original cap, right? So tell me what the original is again.
The original was 180 million.
180 million. So those are the two numbers we want to work with, right? We want to work with the original number and the number that's a difference that you just found. And what are you going to do with those two numbers?
You place them
Absolutely.
over.
Yes, good job. And again, I'm really glad that you wrote some words out there so we don't have to write so many doggone zeros, right? Can you just cross off those millions?
Yeah.
Yeah, you can just cross them right off, right? What about the zeros?
You can also
Oh,
cross off
this
those.
fraction is so much better than the big old fat one we had before, right? So what are you going to do now?
You can simplify it even more by making this 1 and making this 9.
Okay, you
this
divided them
is
both?
1/9 now.
Gotcha. Now, is 1/9 in the form of a percent?
No.
It's not. So is there a way that you know how to change 1/9 into a percent?
So first you would have to change it to a decimal.
Okay, how do we change it to a decimal? That's a good idea.
When a number is over 9, it's just the repeating decimal, which that means to repeat.
Whoa, how did you know that? You're exactly right, but how did you know? I want you to show me. Because this is what you're doing in your head. You were so smart. I can't believe you knew that already. I've never had a student that knew it that fast.
I think she had somebody kind of tell her last week that if it's something over 9, whatever that
Oh
number
man,
is,
that's awesome.
that's a repeating decimal.
Gotcha. Can you show us? Because this is where it comes from. We want to know if we didn't know that little trick, right? This is where it comes from. It comes from dividing it out. So can you divide 9 into 1? There you go. And you're going to see a pattern here pretty soon. There you go. Minus 9, yeah. I'm with you.
And then
Yep.
it just keeps.
It keeps on going. So that's where it comes from. It comes from actually dividing it out. And if you happen to have it memorized, it's even better. But the fact that you know where it comes from is great. Okay, so now you have this decimal. Have we answered the question yet? Remember, the question is, what is the percent increase? Do we know a percent increase yet?
Not yet, because this is just a decimal.
Okay, well, let's take this decimal and see if you can change it to a percent.
To change it to percent, you have to move it over 2 times.
Gotcha.
So it's 11.1%.
And you move the decimal this time two places the other direction compared to what we talked about at the very beginning, right? So I'm glad you did it in the correct
This
direction.
one's decimal.
And this is also an answer that answers my other question, which is, can you have a decimal in a percent? And you can. 11.1% increase.
I knew we'd be able to satisfy all those involved with that
That was
particular
awesome.
problem.
That was
Nicely done.
fantastic. Well done.
All right, hotshot, erase the board. I've got a great one for you
we got
right
more.
now.
Okay, let's do it. If you go way down to the bottom here.
So this is another one of your homework problems, and this is one that I know that a lot of students have had some difficulty with.
Aha, we have a challenge today.
So
We're
we're
up
not
for it, though.
doing an increase or decrease of percent, but we are going to be dealing with percents.
Okay.
All right. So Wally, so just put W up there,
Okay.
earned 1, actually this is going to be a mixed number, so 1
Okay.
and 37 over 42. Okay, that's how many points Wally got.
Oh, points. Okay.
Right. Okay, so Nick
Okay.
and earned 5/6 points.
Okay.
Now here's the question. What percent of Nick's points do Wally's points represent?
Wow.
Okay, so we can write this out like I'm saying. So
Okay.
let's think about the way I'm saying it and then write it out mathematically.
Okay.
What percent, do we know that yet?
Do we know a percent?
Oh no.
So
don't know that
how
yet.
can we substitute percent? What can we put for that if we don't know something?
So we don't know the what. What are you going to
You
put
can
there?
put a variable.
There you go.
like,
What's your favorite letter? K, maybe?
Sure.
Sure, we'll put a K there. All right.
All right. So what percent of Nick's points do Wally's points represent? There you go.
Okay. So
That's-
we made this into a math expression, right? We took the English version, we made it into a math expression. It says K%, right? Because that's a wonderful letter. Good choice. K% of Nick's points equals Wally's points. Does that sentence make sense to you? There's always kind of some things that we know there. Can we start to plug in some things that we do know anyway? Because there's part of it we don't know, but we do know some of it. What does N represent?
N represents 5/6.
Good for you. There you go. By the way, do you know let's change that 9 to a 6 real quick.
Oh, oops.
Do you know what the word of represents in math?
It represents multiplication.
Good for you. That's exactly it. And that's kind of why I'm glad you didn't pick X for the percent, because then we don't get it confused, right? That's good. Okay, so it's 5, what was that fraction again? 5/6. Okay, what about the other side? We have an equal sign. Good for you. And then what's W?
1 and 37/40
Ooh.
seconds.
That's right. 1 and 37 over 42. Do you want to do anything with that fraction? With this is a mixed number. The other one is just a regular fraction. Can you change that mixed number to just a fraction? Is there something you can do there?
You can change it to an improper fraction.
Let's do that, because then I think it's going to be a little easier to work with. And how do you do that?
So you multiply 42 times 1, which
Good.
is still 42, and then
Yep.
you add it to 37,
Good.
which is 79, and then you keep the denominator.
And you keep the 42 on the bottom. Good. So that's the number that's going to be on the right-hand side of the equation. And I like that. I think we'll find that it's going to be easier to work with. Good for you. What about the what part? We still don't know that part, right? We just have a percent. And so that's where the K lines up. Okay, so now it's looking a lot more like math. We don't even have any words left. right? We just have all letters and numbers, which is just some algebra to do here. Wow, this is a good challenging problem. What do you want to do next? We are ready to go here with some math.
So you have to divide 5/6
Good
from
for you.
both sides.
Let's divide by the entire fraction. Yeah.
So
Divide
you
by
just
5/6. Good for you. That's
cross
it.
it out.
Yep.
So if you divide it by 5/6 on this side,
Oh, I like how you wrote that. Instead of breaking it into another fraction, you're going to actually write the division sign. I think that's going to really help us with this problem. Good idea.
you can't really divide fractions, so you can turn it into a multiplication problem
Uh-huh.
by flipping the right fraction.
Yeah.
So it's 79 over 42 times 6 over 5.
Oh, wow. So you know that a division problem is actually a multiplication problem if you flip the second fraction. Good for you. And that k is still on the other side, so whatever we get here, we're going to be able to work on the k, right? That'll be the actual answer. Okay, things are getting kind of interesting now, right?
Yeah.
Would you like a little bit more room on this page?
Yes.
Let's see if I can make you some more room here. Okay, we got some more room. Go for it. What are you going to do with this?
So 79 over 42 times 6 over 5.
Mm-hmm. You want to do any cross canceling there?
Yeah. 42 and 6 can cross cancel, so that's 1, and this is 7.
Wise choice. Tell me how you got that.
Because 6 can go into 6 and 42 one time for 6 and 7 times for 42.
So you divided them both by 6.
Yeah.
Great job. I like it. What's next?
You multiply across, so 79 times 1 is 79, and 7 times 5 is 35.
Wonderful. We have a big fat fraction.
And I'm going to help you out with that to save time.
Wow, okay.
So Kate, over on the left side of the board, I'm going to tell you what this decimal comes out to be. So it's going to be 2.25714, and we're going to stop. It keeps going, but we've got enough now.
Gotcha. Okay.
So that's the decimal, but you still need to figure out a percent.
Okay, we want to change this decimal into percent. Can you do that?
So you move it over to the right
Good for you.
2 times, which would be 2, 2, 5, and then the decimal point would go there, and
Let's at least have one number after the decimal.
Right, because I
Yeah.
think she does have to have one number after the decimal point
Yeah.
for this homework assignment.
yeah.
There you go. We'll just have a 7 there, right? Now, before we finish this part, first of all, is the 7 going to change at all? Will the 1 make the 7 round up or stay the same?
It will stay the same because if it's less than 5, the number stays the same.
Gotcha. And the very last question I wanted to ask you is, let's go back up here and look at this problem, right? It says what percent of n, which is a smaller number, is a bigger number, right? Does it make sense that this number is over 100%? If you're saying what percent, like for instance, what would be 100% of 5/6?
5, 6.
5/6 would be the same thing, right? What would be 200% of 5/6? It'd be double, right?
Yeah.
It'd be double it. So if you look at this number over here, we don't have to know exactly, but is this number double or more than this?
Yeah, more
It
than
is.
double.
It is, absolutely. So we just want to make sure our number, our actual answer, makes sense at the end, because 225% is not a number we use very often, but it seems to make sense in this problem because we're actually going to a number that's more than twice as big as the original.
Right, and the reason I wanted you guys to do that problem is because a lot of students will see that problem and reverse the numbers.
Right.
Because they don't think something can be more than 100% when it can.
Yeah.
Just read the question in the order that it is stated,
Yeah.
and just plug the numbers in where they go, and it will work out like that.
Yeah. And
All right?
translating right into a math sentence was a wonderful way to start. Good job.
Nicely done, Kate, for your great effort so far this afternoon. You've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. And they have got some prime fowl over there. Fill my belly up with that. That's prime fowl. Have you ever heard the word prime?
Yeah.
Yeah. When something is prime, it's really good, isn't it? Have you ever heard of, not to plug any businesses, but one that comes to mind is like Amazon Prime. Have you heard of that before?
Yes.
All right. And there are some other prime examples of prime, and that's what we're going to find out now on today's Language of Mathematics.
Hi, I'm April, and today in the Language of Math, we're going to talk about Prime. So usually what you know about Prime, of course, is Amazon Prime. Prime is all over the place. Some of you may know Prime in regards to a cut of meat. Prime is typically like the best of the best. It's a little different in math. In math, prime is a natural number that's greater than 1 that is not a product of two smaller natural numbers. So what does that mean? Let's look at 3. 3, what kind of number is 3? So when I think, what two numbers can I multiply together to get 3? I can only think of 3 and 1. So 3 times 1 is 3. Are there any other numbers, smaller numbers that I can multiply? The only other smaller number is 2. So 3 is a prime number. Let's take another number. Let's say 12. 12, what numbers can I multiply to get 12? Well, I do know that I can multiply every number by itself. So 12 times 1 will give me 12. And if I think, are there smaller numbers that I can use? I know that 2 times 6 will give me 12. And another set of smaller number is 3 times 4. That also gives me 12. Well, since I have smaller numbers that make that product 12, 12 is not a prime number. What are you thinking about 19? Is 19 prime? Can you think of two smaller products that will make 19? Here is a list of all of the primes. And if we look, 19 is highlighted in yellow, so 19 is also prime. And that is prime numbers in the language of math.
And there we go, the language of mathematics. We have a lot of those that we'll be sharing throughout the year, and you can look forward to those every single Tuesday. So prime, when you hear prime, is that the first thing that came to your mind, prime numbers?
Prime time, Deion Sanders. How about
Prime
that one?
time, Deion Sanders.
Not necessarily a fan, but that's the first thing that came to mind.
Well, yeah, you know what, prime time,
Yep.
right? And prime time, during that 8 o'clock hour, I think
That's
is when it
right.
was, for TV and things like that. They wanted everything to be on during prime time.
Yep.
So usually between 8 and 10. Anyway, 636-4357 is the phone number. We do have phone tutors available until 5:30, most Tuesdays and Wednesdays throughout the regular school year. Right now, we'll go to the phones, and Nathan, how are you today?
Hello. Good, and you?
I'm wonderful myself. What school are you calling for? Where do you go to school?
Cyber Elementary.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. Given that 75% of a certain number is 88, what is 3/8 of that number?
All right. So 75% of a certain number is 88.
Yes.
What is 3/8 of the number?
Yes, correct.
All right. So Scott's here to help you out.
Nathan, what do you want to do with this problem first?
Well, first I was thinking, what is the whole number? Like, try to find the whole number.
Right, we want to find that number for sure. Now, let's just do some common sense real quick. Is this number we're looking for going to be bigger than 88 or smaller than 88?
Bigger.
Going to be bigger, that's right, because we're only taking 75% of it. Okay, good. So how do you want to go about finding this number? What I've written down here on the board is 75% of x, which is what we're trying to find, equals 88. Can you tell me what to do mathematically with this problem next? What do you want to do with that percent? You want to change that at all?
Yeah, turn into a fraction.
Okay, sure. So
It'll be
75
over
over 100. Good.
Uh-huh.
And what about the of? What does of mean?
Multiply.
Right. Multiply times x or some other
88.
number. And we
Yeah.
still have 88 on the other side. All right, it's a good start. So far, now we don't have any more words to worry about. What do you want to do with the 75 over 100 now?
What's it called? Cross multiply it with the 88.
Okay,
Right.
so you're going to maybe multiply by the reciprocal, something like that?
Yeah.
Okay, so on both sides now, we're going to multiply times 100 over 75, which is kind of like we did earlier with Kate. You're actually dividing by 75 over 100, but you have to flip that over. So if you multiply both sides by 100 over 75, On the left side, the 75s will cancel, the 100s will cancel, and you're left with just x, which is exactly what we want. What about on the other side? I'm going to put 88 over 1. We're going to end up with a whole bunch of big numbers here. What's 88 times 100, Nathan?
8,800.
Good for you, 8,800. And on the bottom of this fraction, we're going to have 75. I hope you have a calculator with you. Can you work this out for us real quick?
Yes.
We want to do 8,800 divided by 75.
Okay, so 8,800 divided by 75. 117.33, which will be continuous threes.
Okay, so we got a whole bunch of threes. So we have a decision to make now. We could go back to 8,800 over 75 and reduce it, or we could work with this big old nasty decimal. The reason why I think it might be interesting for us to do a little bit of reducing is because at the very end of this problem, we have to go back and do one more part, and that is to find 3/8 of this number. And of, as you told me earlier in the problem, means times. And so really what we have at the end of the problem is a multiplication problem, 3/8 times whatever number we have here. And so if we could reduce this a little bit, that might be a little bit better idea. Let's go back to this fraction, 8,800 over 75. What do you think we can reduce that by? What goes into both of those numbers?
I know 75 for sure. Let's see what I have.
You know
be
what
nice
I
if it
think
was
might be an
75.
easier way to tackle this problem? Because you guys are going to get into a mess with numbers here.
Okay.
Instead of saying 75 over 100 and dealing with fractions like that, how about if you turn 75% into a decimal? You could have 0.75, but simplify the 75 over 100 first. So how
there we
could you
go.
simplify 75 over 100?
Oh, I like that.
What's the furthest you could get that down?
You will divide that by 25, which will give you 3/4.
Okay.
I like it.
Right, so let's just go with 3/4 and then go from there. So 3/4 of x is equal to 88.
Okay, so instead of using this one here, not that it's wrong, but it's going to give us some pretty big numbers.
Right.
We're going to multiply on both sides. Instead of 100 over 75, we'll multiply times 4 over 3. That's a pretty good deal. So I think we can find this fraction a little bit faster. Nathan, do a calculator for us real quick and figure out what 88 times 4 is.
Okay.
Now, lo and behold, you're going to come out with the same thing.
Yeah, we are actually.
Right, because it doesn't, so what I'm trying to do is see if you guys can figure out the way to, do you mind me kind of helping you out
No,
with this
jump
one a little
in.
bit?
Absolutely.
So we know that we have to get 3/8 of something.
Right.
Now, if you have 3/4, how can you compare 3/4 and 3/8? Can you get 3/4 where you have an 8 in the numerator, or denominator, I mean? What is 3/4 equivalent to?
Oh, I see what you're saying.
You got it now?
Yeah. 3/4, and we want to make that into a new fraction with 8 on the bottom.
Right, we want something with 8s because you have to find 3/8 of something eventually.
So Nathan, if you're going to make 3/4 into 8s, how many 8s would that be?
3/4 to 8.
Yeah. So in other words, on the bottom here, you're going to multiply times 2. 4 times 2 is 8, which means on the top you also have to multiply times 2. So what's 3 times 2?
6.
Good job. Okay, so we have 6 8s here.
Now think about what they're asking you. 6/8 is 88, right? Now you want to know 3/8 of that number,
Ah, okay.
right? So if 6/8, so maybe just write it up there, 6/8 is equal to 88.
Okay. If 6/8 equals 88,
Then we want to know
We
what
wanna know what
3/8 is.
3/8 is. Mr. Kusha, this is making way too much logical sense. I really like how you're
This
doing
is
this.
a little easier way, I think,
The
'cause-
math, I'm telling you, the math would work, but I like the way
Right.
you're going about this problem.
'Cause
Okay, so Nathan, here we go. Ready?
a matter of time.
In real straightforward problem here, right? At the beginning, we know that 6/8 of some number, we don't have to know what the number is, but 6/8 of it is 88. We want to know what 3/8 of it is, right? So look at the numbers 6 and 3. What happened to the 6 when it went to 3?
It got divided by 2.
Absolutely, got cut in half, got divided by 2. So let's do the same thing on the other side. What's 88 divided by 2?
44.
44. So I promise you once again, the math would have worked, but this is a wonderful way to look at it, a little bit more logically, a little bit more idealistically, to figure out this problem without having to go through all the math. And I love being able to solve a problem more than one way. I like that a lot.
There you go. Perfect. So we did kind of do it two ways, but the second way was a little shorter than the first way.
Yeah.
So Nathan, for your great problem right there, because I know a lot of students will be working on that, you've got yourself a meal courtesy of our friends at the Broken Yoke Cafe. So congratulations on that. All right. Well, we are fortunate enough to have a representative from the Bakersfield Museum of Art in studio with us this afternoon. And Ariana, how are you today?
I'm good. How are you?
I'm excellent. So what is your role with the museum?
So I'm an art instructor for the Bakersfield Museum of Art in the Art Reach department, which is associated with the Bakersfield City School District.
All right. Well, you know what? You've got Kate, a 6th grade student, and take it away.
Awesome. Hi, Kate. So today we are going to be doing kind of some geometric shapes. So we have a grid down here that's already been pre-made for you. So go ahead and take your marker. So the reason we have a grid is because every square here is perfect 90-degree angle. So having a 1 inch all around the paper is going to allow us to create these very perfect shapes with the help of our ruler. So go ahead and grab your ruler. So we are going to start off with this hexagon shape here, which is going to be the shape of our cat. So let's go ahead and first find the midway point to our piece of paper. So it looks like it's 1, 2, 3, 4, 5, 6. So go ahead and count 6 lines. 1, 2, 3, 4, 5, 6. Let's go up 1. So we know that this line here, let's go ahead and make 2 little dots. So go ahead and go up. And then on those sides, 2 little dots. And then let's go ahead and connect those lines together. So grab your ruler and let's make that 1 line right there. Looks good. And now we see that we're going to go to the right 1 and then go up 2. So right 1, up 2. Right 1, up 2, make a little dot, and let's go ahead and make that line right there as well. Okay, and we're going to do the same thing, but this time we're going to go to the left. So left 1, up 2. Make a little dot, and let's go ahead and make that line. And then we're going to finish the hexagon, so we're going to go right 1, up 2. So right 1, up 2. And then let's go ahead and connect that line as well. Okay, looks good. And then we're going to do the same thing to the other side. So left 1, actually, yes, left 1, up 2, 1, up 2. And then let's connect these lines. And then we can also make that 1 line up here. And then we can move on into making the face of the cat. So we're going to find the midway point of this little line here. So around this area is where this little square is going to go. So just go ahead and eyeball it and make a little line right at that little center. And then we're just going to make some lines on the edges, and then let's connect that. And then we're going to be making some little lines. Let's make 2 dots right here. So find the center dot, just like that. And then let's connect the edges of the shape we just made to those dots. Okay, looks good. And now let's make 2 dots over here at the bottom, right in the middle of those squares. Okay, and then let's connect these lines we just made to those dots. Okay, looks awesome. So now we can actually work on the nose of the cat. So it's actually going to be an upside down triangle. So let's just make that little line right here. So go ahead and make 1 small line, and then let's point the triangle down. And then we can make one little dot at the bottom of that, right there. And then we can just make this line going down all the way to that dot. And then we make one little dot here, one little dot there. And let's go ahead and just connect those lines to make the mouth of the cat now. Now we're going to make the shape of the eyes up here, which are located in this little area right here. So go ahead and find that area. And we're going to make a little triangle pointing down almost a little bit. Okay, let's do the same thing to the other side. Just like that. And then this line is just going to go out. Perfect. And let's do the same thing to the other side. We want it to be symmetrical. And then we are going to bring this down a little bit. And then let's just bring it all the way out. And let's just connect them at the end. Awesome. And now we can move on to making the big ears of this cat. So we're going to be going from this point here. Let's go to the right. And let's go up 1, 2. 1, 2. Let's make a dot. So now we can get our ruler and connect from here to there. And then we're going to be going up 1, 2. So 1, 2. And let's connect that line as well. Okay, and then we're going to make one little dot right next to the top of the head right here. And then we're going to connect this line all the way over here. And then we're going to make this small detail here, which is just a triangle. So we're just going to get our ruler and just measure out that triangle. Just like that. And then we're going to work on this other ear here on the left side. So we are going to go left 1, up 2. Left 1, up 2. And let's connect that line right there. And then we're going to go up 2. Looks good. And then let's just connect that line right there. And the same thing, we're going to find a little spot right here. Make a line right there. And let's just connect that. And then let's make that little triangle shape that we did on this side as well. All right, and what are we missing now?
The whiskers.
The whiskers. What's a cat without whiskers? So we have our dot here. We're going to make one more dot all the way over here. So make a dot right here. So we have our dot here. Let's make one dot over here. Let's make a dot, and let's connect those two lines. And then we're going to make one small dot, kind of about over here. And we're just going to make just another line right there. So we can have two whiskers. All right, and now let's just bring this whisker down. And then let's do the same thing to the other side. So let's make a little dot, and let's connect those lines. The same thing, let's make one more other dot here so we can form a different line. And then we can just bring the whisker down, and we will be finished with our geometric cat. There you go.
All right, nicely done. So that's one of the many art lessons that you do, Ariana, with the Bakersfield Museum of Art, correct?
Yes.
And if somebody wanted to learn more about the museum, where should they go?
They can find us at bmoa.org.
All right. And I know that you guys have like Saturday lessons and things going on. Do you work with that as well?
We actually have a separate instructor for that for Studio Saturday, and the next one I believe is November 6th.
Okay. Well, I'm sure that Kate had some fun doing that lesson right there, as well as all the students watching. A great math and art all put together right there. Thank you very much.
Thank
And
you.
we'll be back with more right after this.
This week, Lab TV travels to an Air Force research lab in Dayton, Ohio, to meet an engineer who makes very tiny pearls. These are not like your mother's pearls. You can't wear them, and you can't even see them. They're called nano pearls.
I work with nanomaterials. In particular, I work with a material called carbon nanopearls. You can't see it with the naked eye. They're made up of flakes, think of like snowflakes, but tiny flakes of carbon. So these tiny flakes of carbon make this spherical carbon nanopearl. The nanopearl word comes from the carbon nanomaterials being linked together like a pearl necklace. Kind of like seen on here, they're all linked together.
Each of the pearls on this necklace is about 100 nanometers across. And each nanometer is 1/1,000,000th of a meter. So these are really small pearls.
Very, very, very small. You can't see it with the naked eye. Think of one strand of hair, human hair, and it's actually smaller than that. So you can't see that with the naked eye. You have to use a special microscope that uses electrons to look at the image.
So what's so special about nano pearls? Well, for one thing, they're made of pure carbon, and carbon is an amazing element. If carbon atoms are arranged in a rigid network, you get diamonds. But that stuff in your pencil is also carbon. It's called graphite. Those carbon atoms form in layers. So when you write, the graphite layers slide off onto your paper. Lately, scientists have been using carbon to make nanomaterials, like nanotubes and now these little nano pearls. Let's see how nano pearls are made.
You have a tube, a glass tube, and you have nitrogen flowing through the tube. As the temperature is heating up, you want to open the other tank, which has acetylene, to flow through this tube. The acetylene is the carbon source. That's the source you want to use to help grow those carbon nanopearls. So once you hit about 845, you have the acetylene flowing through. And at 850, then that's when the temperature is going to stay there for a good 2 to 3 minutes. And that's when you have a nickel catalyst. A nickel catalyst is something that's there to help the carbon nanopearls grow as well. As the nickel is coming off, you have carbon from the gas that's flowing in, going into that void. So you have nickel coming off and you have carbon coming on, and it's forming that nanopearl.
Like nanotubes, nanopearls are great conductors of electricity. And that has scientists pretty excited.
They're being looked at for flat panel TVs because they can emit electrons, so they could replace the plasma and the LCD TVs that are currently on the market.
The new TVs could use carbon nanopearls to transmit electronic images. It's called field emission display, or FED. Those flat TVs would have great picture quality in a huge durable screen, less than ½ an inch thick.
Everything about materials engineering is exciting to me. You're not just limited to doing one thing. When I started off, I started working with semiconductors, and now I work with nanomaterials. I started with carbon nanotubes, and now I'm working with carbon nanopearls.
And now that she can grow these nanopearls, she's looking for all sorts of uses for them. And who knows, 10 years from now we could all have energy-efficient, long-lasting TVs made from her nanopearls.
I can say, hey, I helped work with that. That's carbon nanopearls. I helped do that. Those TV panels are due to some of the work that I did.
To find out more about nanotechnology, carbon molecules, and carbon nanopearls, check out labtvonline.org.
All right, all sorts of fascinating things to learn every single day. Carbon nanopearls. And you know, a lot of people are probably thinking when they saw that, pearls, you know, my mother has pearls, or my grandma did, and things like that. The World Series is starting this evening, Atlanta and Houston, and pearls on Jock Peterson, one of the guys on the Braves that was traded from Los Angeles, wears pearls. And they're talking about this is a big thing right now, why he wears pearls. Because a lot of these guys usually have like a gold necklace on or something and some sort of pendants hanging from them and things. So it's something a little odd this year. So pearls is a big thing with the World Series this year, and just funny that we had nano carbon pearls on them. All right, anyway, we move on. Let's go back to the phones. Nathan, how are you today? And Nathan, this is, are you, maybe Nathan's not there yet.
Hello?
Oh, there you are, Nathan. All right. So I understand that you have some more math homework problems that you want to work on. And I was just telling everybody that it is fabulous that you are using Do the Math to help you with these math problems. So as soon as you're ready, and I believe I've got the problem that you're working on the camera here. So as you read it, the kids at home can read it as well, and then Scott can take a look at it as well. So Nathan, as soon as you're ready, read the problem.
Okay. Middle school, a sixth grade class of 290 increased by 10%. The seventh grade class increased by 350. Or no, the seventh grade class of 350 increased by 22%. And the eighth grade class of 420 increased by 20%. Overall, what was the percentage increase of the student? Express answer to the nearest 10.
All right, so in sixth grade, we had 390, and it increased by 10%. Seventh grade, there were 350, and that increased by 22%. And in eighth grade, there were 420, and it increased by 20%. So you need to know the percent increase rounded to the nearest tenth. Well, Scott's ready to help you out.
Wow. Okay, we got a lot of numbers here. Nathan, is there a way you can help me to figure out how much the new population is going to be of each grade?
Yeah. So we can turn the percent into a decimal, then times that by the original number.
So we want, so the first one we want 10% of 390. What is 10% of 390?
39.
39, good. So we got that one. And if you add 39 to the original number, right, 39 plus 390, then your new population, right, is going to be 429. So let's go down to the bottom one, and we'll do something similar because those numbers are a little easier to work with. What is 10% of 420?
10% 420. We can just do the same thing we did with the 390.
Yeah, similar process, right? So 10% of 420 would just be 42, but we have 20%, so that's double. So what's 42 times 2?
42 times 2 would be 84.
Good job. That's it. So 84 is 20%. Then we can add that to 420. And at the end, this new class will be 504. So we got those pretty quick. We would like to know now what's 22% of 350. So do you have a calculator with you?
Yeah.
So do 350 times 0.22.
Okay. I got 77.
What's the number?
77.
77?
Yes.
Okay.
Yeah.
Gotcha. All right. So now we have some new numbers. If we add the 77 to the original number, which was 350, 427. So we have some new numbers that are happening here. So the problem asks us to find the percent increase, right? And we had a problem like this earlier in the show. We want to know what's the total original numbers and what's the new total of numbers, and we want to find the difference of those two. So use your calculator. What's 390 plus 350 plus 420? We want to know how many students we had initially.
So 309 plus 404, did you say?
390 plus 350 plus 420. Those are the original numbers. We want to know how much the school had initially, total.
Okay. And I got 1,160.
Hey, well done. So did I. Good job. Now we want to add up the new numbers. 429 plus 427 plus 504.
Okay.
We love those calculators, but it's also good to know how to do it on paper, huh? What'd you get?
Still working out because it was going a little too fast. I couldn't write down the numbers.
429 plus 427 plus 504.
1,360.
That's it. So at least both the numbers end in 60, so that's good. So what we want to do now, in order to find this percent, The original number is 1,160. That's at the bottom of our fraction. And we want to now subtract them, just like we did again at the beginning of the show. We want to subtract these two and figure out the difference. So I think this is something you can do in your head. 1,360 minus 1,160. What's the difference between those two numbers?
260.
Just 200. I like how you did the 200, but remember the 60 is going to go away as well, right? Okay, we're going to take one of these zeros out, and on your calculator, here's our last calculation. What is 20 divided by 116?
3,200.
We want to do a division problem here. We should be getting a decimal, right? 20 divided by 116.
0.17241379.
Awesome. 0.1724. Let's change that to a percent, right? You know how to change a decimal to a percent, right?
Yes.
Okay, so if you would change 0.1724 to a percent, what would it be?
17.24.
Good job. That's it. 17.24%. Now we just have to go back and make sure we answer the problem correctly, because I think the directions said to round it to the nearest tenth. Is that correct?
Yes.
Gotcha. So how do we round this to the nearest tenth? What would our final answer be? 17.20. Yep, 17.2. You can just drop that other one there, right? Great job. Wow, a lot of numbers there. As long as you know the process, the numbers aren't too hard, but you got to know the process about how to get there, right? Well done. I appreciate you bringing that problem to us.
Yeah, nice problem right there. So it goes right along with what Kate was working on, percentage of increase and decrease right there. So come on back up here, young lady. And so I've got a couple of questions for you. First of all, did you enjoy that art lesson over there with Ariana?
Yes.
That was pretty cool, wasn't it?
Yeah.
I mean, just using a little bit of math and counting on the grid right there, you could design yourself a nice little photograph right there. Now, do you like art, doing that kind of thing?
Yes.
Is there a favorite kind you like? Or you're just like, I'm an artistic person, I like doing that kind of stuff?
I like pretty much all art.
All right, good. Well, you know what? The Bakersfield Museum of Art, they've got some great things going on over there all the time. Maybe you'll have an opportunity to go visit them sometime. Did you have fun today?
Yes.
All right. Did you learn a little something?
Yeah.
Excellent. Well, we want to thank Ariana for coming in today with the Bakersfield Museum of Art. And we also want to thank you to Matt Kennedy, the principal at Ronald Reagan Elementary School. And that was pretty sly on your part there. I love my teacher and my principal at the beginning of the show, and we probably threw some people off there a little bit. But Matt was with us 18 years ago, and we are once again celebrating our 20th season this year. So we want to say thank you for Matt for coming in to share a little bit of his experience with the Do the Math program at the beginning of all of this. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. If you do happen to use the email for us, remember to try to do that on a Monday, Tuesday, or a Wednesday at dothemath@kern.org. We can address your problem, get it back to you, and hopefully be able to help you out that way. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.